Okay, so this is the higher unit 2, and this video is on emulsions. Okay, so for emulsions, what we need to know is that an emulsion contains a small droplet of one liquid dispersed within another liquid. Okay, so if the two liquids are of different polarities, they'll naturally separate into layers. Okay, so for example, water and oil. Okay, you get a layer of oil and a layer of water. Think of your esters experiment. You can see the oily layer of the ester. Okay, so because of the different polarities, that prevents them from basically mixing into each other. Okay, so this is where emulsions comes in. So emulsions are used to prevent the two liquids separating, and it's called an emulsifier. So an emulsifier is added in order to prevent the separation. Okay, when an emulsifier is added, you have an emulsion. So looking at this then, so emulsifiers must contain both polar parts, so that interacts with, for example, the polar water, and non-polar parts, so it can interact with the non-polar side. So for example here, oil. Okay, so soaps are an effective emulsifier, which is how they are able to clean in water. Okay, so they interact with the polar water, and then they interact with the non-polar dirt or oil. Although it's very, very important that emulsifiers are not used for anything that is edible. Okay, so in order for an emulser to work basically, it must interact with both non-polar and polar part. Okay, so an emulsion is formed when it's shaking with a non-polar liquid, a polar liquid, and an emulsifier. And what happens is the non-polar becomes dispersed within the polar. Okay, so when you're thinking of your emulsifiers, you're going to look like something like this. So we're going to start with similar to our glycerol. Oh, I can't put it in there. Similar to our glycerol. Okay, add our hydrogens in. And it's really, really important that an emulsifier has at least one OH group, at least. Okay, so after that, we can then put on our non-polar parts. So you could have something like this. Okay, so here we have an emulsifier here. So this emulsifier, we have the non-polar part here, which is your fatty acids that have bonded to your glycerol. We have two fatty acids here that are going to interact with the non-polar part, so the oil part, and we've got this hydroxyl group here that's going to interact with the polar part, so the water. Okay, so it's important that emulsifiers have at least one OH group or one hydroxyl group. At least one. Can't have two, but it can't have three. Because if it has three, then it's not going to interact with the non-polar part or the non-polar liquid. Okay, so here's another example of it. So it needs to have at least one. So it can, as I've said, it can have two. And it needs to have a non-polar fatty acid chain. Okay, so what we call this part here is the part that is going to interact with our polar. We call that hydrophilic. Okay, hydrophilic means water-loving. Okay, so that likes the water, so that's going to interact with the water. It's okay being in water. Whereas your non-polar part is called hydrophobic. And a way of thinking of that, it means water hating. Okay, doesn't like being in contact with water, will not interact with water. Think of your oil. When you put oil into water, it either goes into little bubbles or it doesn't interact at all, it goes in layers on top. Okay, so your polar part that's going to interact with the water is classed as your hydrophilic part, whereas your non-polar part is classed as your hydrophobic part. Okay, so in an emulsion, it's really important that you have a hydrophilic part and a hydrophobic part so that it can interact with both polar and non-polar.